There are two different types of snap tools. The first is the grid tool, which provides global type snaps for translation, rotation, and scale. The second is the vertex snap tools, which provide geometry level snap control. The grid tool is a toggle. One click will activate it while another click will deactivate it. Right-clicking on the grid icon will bring up the grid snap property panel. This panel displays snap settings for whichever manipulation mode the user is in at the moment. If the user is in translation mode, the panel displays the snap units for translation. Click on the tacked object for a demonstration. Note the positioning on the object info panel. With the unit set to the default 1, each snap will move the tack 1 object unit. Note the change in the position readouts. In this case, the units are meters, so each snap matches the grid lines. With the units set to feet, they no longer match. The grid lines themselves have nothing to do with the snap position of this tool and could be turned off without affecting it. Note that the tack will move in Z according to the snap distance, even with no grid lines present. Note that the DynaUnits checkbox on the info panel will force the units for snapping to be the object units. If DynaUnits is off, the snap units will default to the world units for snapping. With the proper settings, this is handy for creating precise arrays very quickly. With a few copies and snaps, we get a nice array of tacks. Clear the scene. If the user is in rotation mode, the panel displays the snap angles for rotation. Click on Fan 2. The default angle is 45 degrees. We will set the rotation snap in Z to 15. Note the change in the rotation readout on the info panel. With a few copies and snaps, we start to get the same array we labored to build previously by adjusting the axis. Clear the scene. If the user is in scale mode, the panel displays the snap ratio for scale. Click on the Bolt 2 object. Note the size. The snap default ratio is 0.2. I have it set to 0.5. When we scale the object, note that it scales 0.5 times the current size on each snap and not 0.5 units each snap. Scale is a ratio. In this case, the new size is 1.5 times the starting size. Also note that scaling smaller is the inverse of scaling larger. Note that the settings on each panel are saved as we switch from one mode to another. Clear the scene and turn off the snap grid so as to avoid strange movement with the vertex level snap tools. Right-clicking on the snap tools will bring up the snap panel. The snap panel provides two controls: distance, set to either screen or world, and backside, which activates points on the backsides of object. Load the Bolt 2 object to the grid. The first tool is the Snap to Grid tool. By selecting a vertex on the bolt and dragging, we can snap the vertex to the nearest grid line or point. Note that the units affect how the snap jumps, and DynaUnits affect whether world or object units are used. Just like the grid tool in function, but on a vertex level instead of an axis level. Again, the grid does not have to be visible for this to work. The next tool is the Snap Vertex to Vertex tool. We will copy the bolt and select a vertex. This is where the snap panel controls come in handy. With the distance set to world, the selected vertex will snap to the nearest point in 3D space, like so, in the XY plane or in the Z direction. Distance set to screen, the vertex will snap to the nearest point in 2D space on the screen. This means that the object height in Z can suddenly change value like so. With backside checked, we can snap a copy to the backside of another. The next tool is the Snap Vertex to Edge tool. The snap panel settings work the same way with this tool as before. This allows a vertex to be selected and snapped to an edge. Once snapped, the vertex can be dragged along the edge like so. The last tool, the Snap Vertex to Face tool, allows you to take a vertex and snap it to a face and then move it around the face. What we end up with is a string of precisely positioned bolt heads.